Good morning everybody. Today we are going to see about real-time software design. We might have seen what is a software design. We have seen basic designs, advanced designs, architectural designs, user interface design. There are various types of designs. But what it is, why it is called real-time software design? What do you mean by real-time? So it happens in real time, that is, it gets inputs on the spot from various sensors, actuate sensors, or some computer devices, or some hardware devices, or from a printer, or from an input, or from an individual. So there are so many chances for getting the input at real time. So hence it is called, and designing such a software is called real-time software design. So real-time software design, it is nothing but designing embedded software systems whose behavior is subject to timing constraints. So it depends on the timing. So a system is said to be real time if the total correctness of an operation depends not only upon its logical correctness but also upon the time in which it is performed. So it is not that just the functionality happens here, it is also dependent on the time at which it is performed. Those sort of systems are called as real-time systems. So now we will see designing of that real-time systems. So these systems, real-time systems, which monitor and control the environment. Monitoring is nothing but just seeing what is happening around it. Controlling is taking actions according to the monitoring input. So in this case, in real-time systems, time is very, very critical. So real-time systems, it depends, it must respond within the specified time. So that is an inevitable, or what to say, it is an important factor over here. So the hardwares which is mainly associated with real-time systems are sensors and actuators. We already know what is a sensor. Sensor is nothing but a device which collects data from the environment. It could be a temperature sensor, smell sensor, or it could even be a humidity sensor, or a water content sensor, fire sensor. There are numerous number of sensors, even an intruders detecting sensor. Actuator is nothing but, again, it is a hardware part which makes the functionality or makes actions to the system's environment. So it changes the system environment according to the sensor's input. Coming to the definition of this, a real-time system is a software system where the correct functioning of the system depends on the results produced by the system and the time at which these results are produced. So there are two things to be taken care. It is based on the results produced as well as the time at which the results are produced. This real-time system can be categorized as soft real-time systems and hard real-time systems. The soft real-time systems are nothing but whose operation is degraded if results are not produced according to the specified timing requirement. It has functioned, but it has not produced the results as per the timing requirement. So it will degrade the system. So that is a soft real-time system. What is hard real-time system? Whose operation is incorrect if results are not produced according to the timing specification. So there only degradation in the operation. So it is called soft real-time system. Hard real-time system is when it is not operated in the correct time, the system is said to be incorrect. So it is of no use. So that is called hard real-time system. Okay. So what is a stimulus and response system? So we have seen two important hardwares with respect to a real-time system, that is sensor and actuator. Stimulus and response system is related to those sensors and actuators. Given a stimulus, the system must produce a response within a specified time. So what is a stimuli? Stimuli is nothing but an input signal. Okay. So this stimuli could be periodic or aperiodic. What is periodic? That means the stimuli occur at periodical time intervals, that is predictable. Say for example, a sensor is giving the input within every 10 seconds. So it gives the input every 10 seconds, or it could be 10 times per second, something like that. So there is a time bound thing, and it is also periodic. Each second it gives an input, or for a second it gives 3 inputs, 4 inputs, something like that. So you have a defined way of giving the stimuli. Aperiodic stimuli is, so it is at unpredictable times. We cannot predict it. So for example, when power goes off, it gives a signal. So we cannot predict power goes off in next 5 minutes or next hour or after 10 hours, we don't know. So even it could be the next minute. So for example, a power failure may make a stimuli or make an interrupt or create a stimuli that is called a periodic stimuli. But the periodic stimuli is nothing but where the inputs are given by the sensors at periodical time intervals. A change in the environment that can be detected by a sense organ and brings about a response. So now we see what is a stimulus and response in a simple manner. Say for example, if we touch a hot pan, which is a hot pan with a metal handle, the stimulus is the heat in the handle, but the response is we leave the handle. Am I right? We touch it and we feel the heat, we leave the handle. That is the response. Stimulus is the heat and response is the action which we have performed, that is leaving the handle. So that is a stimuli and response system. So architectural consideration for this real-time system is it should allow for fast switching between stimulus handlers. So timing demands of different stimuli are different. It is not that all stimuli will have the same timing intervals. These real-time systems are usually designed as cooperating process with the real-time executive controlling this process. So these three things should be taken care while designing. So a simple block diagram of a real-time system. So you could see a real-time control system, which is the middle unit, where you get inputs from so many sensors, and the real-time control system produces outputs and triggers the actuators to make a change in the environment. So it is not that for each sensor you need an actuator. Sensors might be higher, actuator might be less. Okay, there is no restriction or a clear one-to-one strategy that for each sensor there should be an actuator. So even inputs from 2-3 sensors, the output could be decided by a single actuator. So sensor will produce a stimuli which is given to a sensor control, which is again gets processed in the data processor, and it gives the output to the actuator control. The actuator control generates the response given to the actuator, which makes the control the environment. Okay, so we have three important parts here. One is sensor control process, data processor, and actuator control. So now we will see how a system design happens. So we have to design both the hardware and software associated with the system. So first we have to partition the whole system as hardware and software systems. After preparing the systems separately, we could integrate it together. So design decisions should be made on the basis on non-functional system requirements. You all know that as per the definition of real-time system, it is not only the functionality, it is also the timing constraints which take care of the real-time system. So timing is nothing but a non-functional system requirement. So hardware delivers better performance, but potentially longer development and less scope for change in case of the system design. So first we have to establish the system requirements, then we partition the requirements as software requirements and hardware requirements, and we do the software design and hardware design separately. This is the step-by-step process of preparing a real-time system design. So first we have to identify the stimuli to be processed and the required responses to these stimuli. So what are the stimuli and what are the responses? Then for each stimulus and response, identify the timing constraint. We have already told that all stimuli will not have the same timing constraints. Third one is aggregate the stimulus and response processing into a concurrent process. So a process may be associated with each class of stimuli response. It should be a concurrent process. Fourth one, we design algorithms to process each class of stimulus and response. So algorithm is to be designed. Then we have to design a scheduling system which will ensure that processes are started in time and meet the deadline. So scheduling will help you to make which process to be done first, which one to be the next one, and what is the time needed for each scheduling, each process. Last one is integrate using real-time executive or the real-time operating system. These are the 6 steps of real-time system design process. I think you might be very clear now what is a real-time system what is a real-time system process, what is periodic stimuli and aperiodic stimuli, what is stimuli and response, all those things. State machine modeling is the effect of stimulus in a real system may trigger a transition from one state to another. So finite state machines can be used for modeling this real-time systems. However, FSM models doesn't have a proper structure, so which results in complex models. So UML is a best method for doing state machine modeling. So over here I have simply shown a microwave oven state machine which we have seen in the previous lecture as an example for state machine modeling. Coming to the last part, I have just given an assessment part here. Can you match ABCD with the right side parts? Okay, I will come with the answers. So matching of the sensor could be matched to, please tell. Actuator is nothing but response. Periodic stimuli is time sensor. Aperiodic stimuli, power failure is an example of aperiodic stimuli. Then sensor will create stimuli. Okay, that is the matching part. So requirements are categorized as functional and non-functional requirements. FSM stands for finite state machine. UML stands for unified modeling language. Thank you all. This is the end of today's session. We will see with an interesting topic in the next session. Thank you all. Have a good day.